In this video, I will explain you electric field due to a shell of charge. So we have a shell and that is charged. So inside a hollow it is, and the charges are distributed on the surface. Now it will be the same case if you are taking a solid sphere, but it should be conductor. So even though if you are giving a charge of certain positive inside, all these charges will be repelled and these charges will be taken outward. Why? Because these are conductors and conductors allow movement of charge. So this conductor allow movement of charge and these charges will be residing at the surface. But if this is an insulator, we can't apply this. With insulator, whatever the charges we are giving inside, that will be inside itself. Okay, so with both the cases, I can conclude a particular result which I am going to explain here. Okay, now what will be the electric field due to this shell at this point? What we have to do? So we have to consider a Gaussian surface. Okay, so this is the Gaussian surface here. Now electric field lines are passing through the Gaussian surface. We know. Okay, as per Gauss's theorem, I can say the total flux is equal to 1 by epsilon 0 times charged enclosed. Let's say the total charge is capital Q. So this will become 1 by epsilon 0 times Q, because the charge enclosed by the points outside the shell. So this can be written as, if this is capital R is the radius of the sphere and I am going to take points at a distance R away from the center where R is greater than R. Okay, where this R, the points which I am considering to make Gaussian surface, these are all small r is greater than capital R. So in those cases, my Gaussian surface completely encloses the charge. Here also it will be the scenario that completely encloses the charge. Now here we know that this is the area, this is the electric field, area, electric field, area, electric field. So always my area and electric field are parallel to each other. So this is nothing but we have only one area here. Okay, so what is the value of flux? Flux is equal to E into A into cos theta, E into dA into cos theta is equal to Q by epsilon 0, and E at all the point is same because it is equidistant from the charge. So E into cos theta. What is cos theta? Cos, here angle is area and electric field make an angle of 0. So cos 0 is equal to 1. So here cos 0 is 1. So E into dA into cos 0 integral. This is equal to Q by epsilon 0. So this is equal to, E is constant everywhere, so E can be taken out, into cos 0 is 1, integral dA is equal to Q by epsilon 0. Now what is integral dA? It is nothing but a sphere having a radius of r. So total area will be 4 pi r square. So E into 4 pi r square is equal to Q by epsilon 0, and E is equal to Q by 4 pi epsilon 0 into r square. So this can be written as 1 by 4 pi epsilon 0 Q by r square. We have learned that this value is electric field due to a point charge. So this can be considered as the total charge of Q kept at the center. Okay, so this scenario where we are considering the electric field at this point, at this scenario we can consider that all the charges are now kept at the center and we are finding electric field due to that charge at this surface, which will be due to a point charge of Q, at a distance r away, what will be the electric field? 1 by 4 pi epsilon 0 q by r square. It is the same value. Okay, so outside this will be the value. Now what will be the value inside? To get the value inside, we have to find electric field. We have to consider a Gaussian surface inside. So obviously from this diagram itself, it is very clear that there is no charge enclosed by the Gaussian surface when we are considering in this way, which means when r is less than r, those points we are considering, we have got a Gaussian surface in this way. Okay, so inside the Gaussian surface, the total charge enclosed is 0 because the charges are outside, but outside charges has no influence over here. Okay, now this is equal to integral phi E is equal to E into integral E into A into cos theta, E into dA into cos theta is equal to 1 by epsilon 0 times charge enclosed. Anyway, A is not 0 here. It is a non-zero value of A. So see, 1 by epsilon 0 into charge enclosed is 0 inside this. So the total value is 0. See, when two numbers are multiplied, the value has become 0. Out of that, area is not 0, which means E is equal to 0. This is very important relation. See, inside the shell, E is equal to 0. Here also, if you are considering an area in this way, here there are no charges enclosed, electric field inside will be 0. Now what will be at the surface? To get the value at the surface, we can just substitute the R is equal to R, that is R is nothing but position of the point where we are finding electric field from the center. So that R, when we are considering as capital R, then we will get the value of electric field. So this is R less than R. This point is R greater than R, R greater than R. Now for the cases, so I'll mention it here. R equal to R, what I can do, instead of small r, I will substitute capital R, which is E is equal to 1 by 4 pi epsilon 0 q by r square. Here also it will be the same case. Now we will plot a graph. See, this is electric field, y-axis. This one is electric field, y-axis. X-axis is R. This is x-axis. Now we are starting from here. Electric field 0, 0, 0, 0, 0, 0, 0, 0. Till surface it is 0. At surface the value is q by r square. Now after surface, when we are increasing the value of r, when this increase, the electric field will decrease, which means till point r, when we keep increasing r from 0 till r, the value is 0, electric field is 0. Now at r, it's a maximum value, and the value is 1 by 4 pi epsilon 0 q by r square. Now after r, what will happen? That will decrease. So this is r greater than r, this one is r equal to r, now this one is r less than r. And here we know that it is inverse square principle. So electric field is inversely proportional to r square, we can mention in this way. So it is the same case for shell and also for solid metallic conductor. What is the reason? At metallic conductor, these charges will be residing at the surface, it won't go inside. So that is nothing but the same case of a charged shell. This is very important. This graph has asked multiple times. So E is equal to 0 till here, and at here it is the maximum value. So at surface it will simply behave, at surface and beyond surface, this will behave as a total charge of Q placed at center. So we are just simply substituting the values in a known equation of this. Very, very important. Okay, thank you.